Well, everyone, let's get the show on the road. Our last topic is going to be the chain rule. We'll get that finished today. On Monday, we'll have a review for the final, but if I can do this a little bit quickly, I might be able to give you a quick intro, at least to tell you how to calculate the number of points you need to get in the final to graduate, to get a 2-point at least. So let's show you the problem. The chain rule is basically from Calc 1. It's when a function, it's like a function of a function. Well, the way it works in multivariates goes something like this. Imagine you've got, this is a version of question 1. Imagine you've got z and it's equal to x squared y plus xy squared. Now, if I just asked you to find the partial derivative with respect to x, I hope you're comfortable with that, right? Right? That guy gets you 2xy and that guy gets you y squared. So what we're now going to add is an extra piece of information. And in this extra piece of information, we are told that x is 8t and that y is t squared. So you essentially, z is a function of x and y, but x and y are themselves function of another variable called t. And what you are typically going to be asked to find in these chain rule situations is you're going to be asked to find the derivative of z with respect to t. And there is a formula for it. The derivative of z with respect to t is the partial derivative of z with respect to x times the derivative of x with respect to t plus the partial derivative of z with respect to y times dy by dt. And this is called the chain rule formula for one variable. And you might say, what do you mean by one variable? I mean this guy here. X and y are in terms of just one variable. Now, if you look at the formula, the derivative with respect to z of t is the partial derivative zx times dx by dt plus the partial derivative of y as z with respect to y dy by dt. If you think about it, don't these dx's and dy's cancel out and you've really got the contribution to the derivative from x plus the contribution of that derivative with respect to y. Also, there's some notation subtleties here. Have you noticed that these are normal d's and these are partial d's? You see that? dx by dt is a normal d, and that's because isn't dx by dt a pure one-dimensional derivative, not a partial? And dy by dt, same thing. On the other hand, dz by dy are partial derivatives. So you see you're doing partial derivatives of this. Now, the questions where this situation is occurring, I'm going to write them down right now, is questions 1. Question 2 does the same thing. Question 3 uses the same formula. Question 4 is just an extension of that one. And that's it. So the first 4 questions, you can use this version of the chain rule. So let me do it. The derivative with respect to t, right, dz by dt, is the partial derivative. So that's 2xy plus y squared times dx by dt, which in this case is just 8, plus dz by dy, right? Well, if I differentiate this fella with respect to y, I get 2xy, and let's do that again. I get x squared plus 2xy, that's better, times the derivative of y with respect to t. And so what you're looking at right now is essentially the answer, right? It's that. But that is not going to be the end. What do you think you are expected to do in a question like this, where you're being asked to find the derivative of z with respect to t, do you think you should leave everything as x, y's, and t's? So would you agree it makes sense that everything should be turned into t's? And how am I going to do that? Well, every x is going to be 8t, and every y is going to be t squared. So it's going to be 2 times x times y plus y squared. I guess I'll leave the times 8 for the time being, plus x squared, which is 8t squared, plus 2 times x times y, finally finishing with 2t. And God in himmel, that's a mess, but here it goes. 8 at the front, 16t cubed plus t to the 4. I'll stick a 2t at the front here, and that's 64t to the 4 plus 16t cubed. Then I'll 80 and 48. Good grief. 48 and 80, 128. And 8 of these guys, and 128 of those guys, and 32 of those guys. And finally, after a lot of moving stuff around, I believe that the answer you get is that. Are we comfortable about the process of finding dz by dt using this chain rule formula? So can you imagine z's just going to be x cubed y plus sine x the next time, and x is going to be t cubed and y is going to be t plus e to the t, right? They're just going to change the details, not the essence of what it is. So let me try a version 3 then. In this time we have z, and it's an x take away y over an x plus 7y, and x is e to the pi t, and y is e to the negative pi t. And let's find dz by dt. So I'm just repeating my formula from before. Now, if you do a partial derivative with respect to x of this guy, you are going to have to do a quotient rule. And differentiating x with respect to t just gets you that guy. And if you want to differentiate this with respect to y, you're also going to have to do a quotient rule. And if you differentiate this guy, you get negative pi e to the negative pi t. Okay, let's do this one back to x's again. So if you differentiate the top with respect to x, you get 1. Leave the g alone. Take away, leave the top alone and differentiate with respect to 1. And the whole thing is over that guy squared. And you're still going to multiply it by that fella. And I'm running short of room here, so I'm just going to do it underneath. If you do this fella, but with respect to y, you get f dash, which is negative 1. Leave the bottom alone. Take away, leave the top alone, and differentiate that guy. And the whole thing on the bottom gets squared. And you multiply it by that horribleness. Okay. I'm going to stick this fella at the front. If you do this guy and you take away with that guy, what do you get? X take away X, go away. 7y, take away a negative, adds it, you get 8y over that guy squared. This guy can go here. -1 times this guy gets you negative x. Take away 7, so it's negative 8x. 7y with the negative, they cancel out. Okay, that's fine. And on the bottom, I get that guy. Okay. So what do I have now? I'm going to. Do I really need to do much? I guess I could. I'm trying to think of what I can do to make this pretty. I'm going to pull out a pi that I can do. I'm going to pull out an 8, and I'm going to pull out an x plus 7y squared, because each of these contain those 3 terms. I still have an e to the pi t to deal with, and a y. And I have a take away an e in negative pi t times an x. And you might think, and I'm glad you don't need to, that I'm going to turn all these x's and y's into these guys. And there would be nothing wrong in doing that. But thankfully, WebAssign is happy to leave it kind of half done. You agree it's kind of half done, it's got x's, y's, and t's in it. But really, if you wanted to be a perfectionist, thankfully we don't need to. All the x's would get replaced by this, and all the y's would get replaced by that. I think this might turn into something quite nice if that happened. But if you don't need to do it, let's just not. The last one of this is question 4. And we have a function w, which is x e to the power of y over z. And x is a function of t, y is a function of t, and z is also a function of t. And we're being asked to find, using a chain rule formula, that guy. Now, it's a little bit different. Isn't this got 3 variables, whereas the earlier one had 2? So we have got to adapt this formula to take account of the fact that there's 3 variables, x, y, and z. So it's going to be, whoops, dw by dx, dx by dt, plus dw dy, dy by dt. How do you think I'm going to adapt it to this situation? What extra do you think I should add here?
Add the partial derivative of w with respect to z times dz dt.
Does that make sense? Because that's what you do. We're not doing it, but can you continue this chain rule formula for 20 variables? I mean, nobody in the right mind would want to, but you could theoretically. I believe this question also allows you to mix up the x, the y, the z's, and the t's. So remember that earlier question where I didn't turn everything into t's? This question, we're going to kind of leave it that half kind of done step where there's x's, y, z's, and t's in that answer. So if you do a partial derivative of this guy with respect to x, you get e to the y over z. If you differentiate this with respect to t, you get that. So that's the first piece. Add. If you differentiate this with respect to y, you do get x and you do get e to the y over z. What else do you get? If I differentiate partial derivative of this with respect to y, I do get this, but what else do I also get?
One over Z.
Okay, which I'm just going to write that way. And then dy by dt is just what? The number -1 in this case. Right? The third and final one is the horrible one. If you want to differentiate this fella, partial derivative, with respect to z, you will get x e to the y over z. What else will you get with that one? Because you've got a y over z to deal with, right? So what does that end up getting you?
-1 over Z squared.
Negative y over z
Oh.
squared. Because that y is like 5 over z or 10 over z. Right, now all I'm doing here is vaguely tidying it up. I'm going to pull out the e to the y over z because pretty much all of those terms have it. I have this one, that guy, and that guy, I believe, gets me negative x over z. That guy, and that guy gives me negative 5xy over z squared. And that's as good as it needs to be. If you were being a purist, wouldn't all the x's, y's, and z's that you see here, here, and here, wouldn't they all get replaced by this? And the thing would probably be that big. So maybe that's why they chose not to do it. Do you feel comfortable then if I give you a function z in terms of xy or xyz, and each of the variables is in terms of t? Do you feel comfortable you could generate the chain rule formula for the whatever situation you've got and do the bits, either turning it all into t's or leave it in this kind of halfway stage, depending on what the answer is? When you're doing your homework questions, you might want to put in the half done stage. If it takes it, that's great. If it's correct, but it doesn't take it, then it's one of these questions where they expect you to go all the way. Because it's not that clear to me why they decided sometimes to do, turn it all into t's, and why sometimes they just decided to leave it this half done version. Well, they're only essentially another layer to the chain rule. And the first example of that is going to be question 5. And it starts off that z is a function of x and y, nothing new here. What do you think the next level up of complexity would be? Right now, we've done the z as a function of x and y are both functions of t. What do you think they might do to up that level? But instead of x and y being a function of just one variable, t, they make it a function of 2 variables, typically s and t. Does that seem kind of logical? That would be maybe the next stage. Now, the chain rule exists, right? That's the name that we give to the formula that we're going to use to find the partial derivatives. But in this case, there are 2 questions. Couldn't you be asked to find the derivative with respect to t and or the derivative with respect to s? Do you agree? So let's see if we can figure out what this version is. Now I'll bring this guy that we've used before and see if we can adapt it. What do you think the formula would look like? Any takers?
I think it would just look like the previous one, except when it says like dx over dt, you make that a partial derivative.
So if I'm picking it up correctly, you're saying that.
Yeah.
And the good news is that's exactly what you do.
Yeah.
Right. Essentially, isn't this piece the contribution to the answer using x's, and isn't this piece the contribution to the answer using y? Now, do you notice that everything is now delta, there's no d's, and the reason for that is, isn't everything got more than one variable in it, right? So everything's a partial derivative. So let's see what we get. If you differentiate this with respect to x, you get 2x, and if you differentiate this with respect to t, you get 7. If you differentiate this with respect to y, you get 2y. And if you differentiate this with respect to t, you get 1. So I guess the answer is 2x plus 2y. Do you think they are going to leave it in that form for this particular question? Or what do you think we're going to do to finish it off?
Wait, why wouldn't it be 14x?
Oh, 14, yeah. It should be. Do you think we're going to leave it as 14x plus 2y, or do you think we should do more? What would be the more that you would expect to happen in this question? Because it's relatively easy to do, probably. That's why they're letting you do it.
I mean, the S&T functions for x and y.
Yeah. So 4 s's plus 7 t's, add 2 lots of s and t. You know, I put funny little marks in my s's because they look like 5s if I don't. If you're wondering why I'm doing that. 40 that.
So
Yes.
are we doing dz over ds or dz over dt?
This better be dz by dt.
Okay.
But the answers are going to have s's and t's in them. Oh, and by the way, it's partial derivative. That's why s's and t's are in the answer. So 56s, 28t, add 2 more s's and add 2 more t's. So I hopefully can add correctly 58s plus 30t. Now, you might be thinking, wait a minute, when we did it before, the answer had nothing but t's in it. But that was because wasn't x and y only function of one variable t? Because x and y are functions of 2 variables, do you see that when you do this version, it's not uncommon for your answer to have 2 variables in it? Are we good with that question now? We comfortable with the s's and t's and where they came from? Right now, the guys that belong in the same family as that one, obviously question 5. Question 6 is essentially the same thing. Question 6, I don't know how to phrase this, I'll call it mixed. So in question 6, you would leave the answer as combinations of x's, y's, s, and t's, right? You do that half-finished version again. Question 7. Same method as this. Question 8. Same version. Right. So far, so good. I'll pick one more of this type. No particular reason, I'll pick 7. In question 7, z is the sine of theta over r. Theta happens to be s to the 7 plus t to the 7. And r happens to be s times t. Okay, got all the pieces. Now you want this fella. Let's do dz by ds, just to be different. So it would be dz by dx, dx by ds. So that's the contribution of x's to the answer. And dz by d, why am I calling it x? R's and thetas. Let's start again. dz by ds then. dz by dr, dr by ds, plus dz by d theta by ds. So if things work out, the r's cancel and the thetas cancel, and you're left with two contributions, dz by dt's. If you differentiate this guy with respect to r, you get negative sine theta over r squared. If you differentiate r with respect to s, you get t. Plus, if you differentiate z with respect to theta, you get cosine theta over r. And if you differentiate theta with respect to s, you get 7s to the 6. And there's really nothing much you can do to make that pretty. I guess I could maybe try and write it a little bit nicer. You could pull out an r as a common factor, but I don't think there's any great benefit in that. So I want, there's your answer. It's got a mixture of the variables r and theta and the variables s and t. And that's kind of the version that they'd be looking for. Are we good on this general? Isn't it just basically finding partial derivatives? But instead of just having a normal function, you've got a normal function, but each of these is in terms of a newer variable. Now they have a special case here in question 8. And it's just an extension of this situation that we've just done. No, so 8, I think 8's fine. I think it's 9. It is. Let's redo that. 8's just like this one. Question 9. That's a special case. Z is equal to x to the 4 plus x squared y, and x and y. Well, x is a function of s, t, and u, and y is a function of s, t, and u. So z is a function of 2 variables, x and y, but x and y are themselves functions of 3 variables. Okay. We need to create the chain rule formula for this combination of variables. Now, dz by ds is what we're being asked. So what I would do is I'd say, okay, dz that fella, dz that fella, the contribution with x's and the contribution with y's. And I wish I'd gave myself a little bit more room. Wait a minute. Are we finished? Is there anything missing? No. For a minute, I thought it was the third term, but that's because there's 3 variables there. But actually, there are 3 things. Isn't that the 3 things you could end up calculating? You could be asked to find dz by dt or the partial derivative dz by du. So that formula is actually not any different from the others. And I want to go dot, dot, dot. So I'm just going to leave that because we're so question 9, question 10 is going to look very similar to that one. Okay, on to 11 then. We're almost finished. P is equal to the square root of u squared plus v squared plus w squared. U is a function of x and y. V is a function of x and y. And w is a function of x and y. And we are going to have to find that guy. Okay, I need a chain rule formula that is going to make that happen. Any takers for what that formula would look like? You know, it's going to be 2 things multiplied. It's going to have that kind of shape. It might have 3 bits. Don't they all start with a guy that looks like that? Again, there might be 3 bits. What's this guy going to look like?
You got dp over du times du over dx.
You got it. And next one.
dp over dv times dv over dx.
And there is a third one and a final one.
dp over dw over times dw times dx or over dx.
Are you all happy about why that one needed 3 pieces and what the 3 pieces are? Now, there are so many combinations. Couldn't you do a 5 variable function where each one of the 5 variables was in terms of 3 other variables, right? Couldn't you do some weird combination 2 and 2, 4 and 1, 7 and 9, who knows, whatever. So don't you have to adapt the chain rule formula to account for the number of main variables? So if there's 3 of them, there's going to be 3 pieces to your answer, right? If this was 2, there'd be 2 pieces to your answer and so on. Now, if I'm going to differentiate this guy, it's probably a good idea to call it that. Agreed? Would you also agree that this is a symmetric function? So here goes. If you differentiate this fella with respect to u, you'll get 1/2 u squared plus v squared plus w squared to the negative 1/2 times the derivative of what's inside, which is 2u. And I'm going to rearrange all of that and turn it into this guy. So that's just this piece here. And then you differentiate u with respect to x. So if you differentiate this guy with respect to x, you get an e to the y. Now, dp by dv. I could go through all of this, couldn't we? But by symmetry, if you differentiate with respect to v, wouldn't you expect to get that answer? And then you can do dv by dx. And if you do dv by dx, which is this one, you get a y e to the x. Now, dw by dx ends up being y e to the xy. What would the derivative dp by dw be? I mean, I could go through all this working again, but shouldn't we be able to use symmetry? dp by du, dp by dv. What's dp by dw? Any takers? That's
Isn't
the
that W over everything?
Yes. Okay, let's make it pretty. Everybody here has the same bottom, so I'll stick that in. On the top, I've got that term. I've got that term. And I've got that term. And this question is happy with things just being a whole mess, a mix. Are we comfortable about how we adapted the chain rule formula to account for a 3 variable function where each of the variables was in terms of 2 new guys? Because if you can create this guy, it's really plug and chug, right? And we are finished. Yay. So for the last few moments, we only have 5 minutes or so, let me tell you a little bit, and on Monday we'll go into it in a lot more detail because Monday is a class day. It will be a review for final. But you would like to know, I'm assuming, what do I need to do in the final to pass, to get a 3.0, to get a 4.0? So let me show you what you do. Can we pretend that your grade is 87%, right? Take your grade, just to 87, and multiply it by 7. So 87 multiplied by 7. This particular person has 609. If you're interested in it, it's actually 609 out of 700 points. And I call that your raw score. So I'll put it over here, 609. Now, you need to get 750 points for a 2.0. Take your raw score, subtract it from that, and in this case, what do you get? You get 141. So if you want a 2.0, you need to get 141 in the final, which is going to be worth 300 points. So that's how you figure out what you would need in your particular situation, right? So if you're a 90%, wouldn't you go 90 times 7 to get your raw score? And then that is what you need. Now, you might be more interested in thinking, what do I need to get 3.0? Well, you need to get 850 points. And that ends up being 281 out of 300. Now, can you see that is a pretty hefty challenge, right? Getting 90+% in a final is not easy, but doable. It's happened. And some of you might even be thinking, I wonder what I need to do to get that magic 4.0. And the answer for this person is it's not going to happen, right? Every 10 points that you get in your final moves your GPA up 0.1. So for instance, suppose you got 151 in the final, right? Basically 50%. You would be a 2.1. If you got 291 in the final, you would be a 3.1, and so on and so forth. Does that make sense? How you can use what you... The only minor, and it's very minor, I guess it could make a percentage difference, but that's about it, is that your last homework has to be done. Obviously, if you screw that up, you might get a 93% as your answer instead of a 94, right? But, you know, let's assume that that's done. Now, the final, there is, and if there's not, I will definitely be looking for it because I know there's one somewhere. There's going to be a practice final put on Canvas for you to look at. Your final exam is going to be made up of 2 sections. The first one, section 1, is multiple choice, and there's 10 questions, and that there are 10 points each. So there is 100 points. So you're going to get a question and the answer is A, B, C, or D, right? A multiple choice. That's what section 1 looks like. In section 1, I won't expect to see answers. In fact, I won't even look for working. All you will do is circle the correct answer and call it good. If you're doing multiple choice questions, any shortcut you can think of, any lucky guess is equally valid, right? If you think that you need to do something that's going to take 15 minutes, actually, if it takes more than 5 minutes, you're doing it wrong. If it's a multiple choice question, you should be able to get the answer in 5 minutes or less. If you think, oh, I'm going to have to integrate this and then I'm going to have to do that afterwards and draw a picture and who knows what else, that ain't the way to solve this. So pick C and move on. Everything is going to disappear except one section, one module in Canvas. And in that module, there'll be a PDF of your test. There will be a link to upload your work. And there will be a Zoom link so you can click on it and join me so I can see you. That's pretty much it. Everything else, all the help, all the good stuff that you've got as resources will disappear. All homework references will disappear. So that means you've got to make the best notes you can. Because can you pretend for a minute that you didn't write down how to do the chain rule? Isn't that going to be a real pain in the butt if I give you a chain rule question and now you can't remember what the formula is and you don't have it written down somewhere where you can get it? You are allowed to use anything physically written down, PDF included, right? Section 1 doesn't need any working. Section 2, you have to show me it. There are going to be 10 questions at roughly 20 points each. There's your other 200 points. Section 2 needs working. If you just tell me the answer is 42, you're getting a big 0 out of 20. I could go into Mathematica or do some other software places out there and they will just tell me it's 42 or 4x or whatever the answer is. If I don't see the working, then you didn't do it as far as I'm concerned, right? And don't tell me you're that much a genius, which I'm sure a lot of you are, that you did it in your head. Because I'm just going to say, tell me what was in your head and write it down now. Because nobody has got a brain where they can't describe what they did to get the answer, right? Not the kind of questions that we're doing, right? I'm not asking you to tell me how you did 2 add 2. Okay, that would be hard to explain, right? We know it's clever stuff. Section 1 and section 2 are chronological order. So the first thing you're going to see is stuff from week 1. And the last question you're going to see is stuff from this week. Half the things that you study for in the final will not be in the final. So you might be really, really good at doing the chain rule, and then I just don't give you a question on it. But you know what happens. The half you don't study for is the half that is in the final. So you have to assume anything is possible. When you see the practice final, just because I didn't put a particular question in the practice final is not me giving you a hint, nudge, nudge. That's not going to be in the final. If I did a practice final with every single thing I could ask you, it would be so big, I'd still be writing it right now. It's a taster of how things look. You know what your tests look like, right? You know what the way I ask things. So there won't be anything, what the heck is he asking? I've never seen a question phrased like that before. Except occasionally in multiple choice, I get you thinking questions. And that's fine because multiple choice is an A, B, C, D, right? And you can think. That's kind of it. I'll give you an example of a thinking question. Suppose I tell you that that converges, and I tell you that that converges. And I ask you, about that guy. And the answers might be, it always converges. B, it never converges. C, it sometimes converges. Or D, there's not enough information. Which is the right answer? Because that's a thinking question. There isn't a calculation you could really do to solve that problem. What do you think it is? A, B, C, or D? Can you see in a multiple?
Converges.
I like your answer because it's right. And that's all you need to do. You just need to do C. I don't need a written explanation of why it's true. Do you want to explain why you believe it's true?
Okay, so I know the top's going to converge. I know the bottom's going to converge. But if the bottom converges significantly faster than the top, then we're going to have, 0 on the bottom, infinity, 0, anything divided by 0 is going to be infinite. So we're going to stop converging because we're going to start dividing by 0 or near enough to 0 that we're going to go up to infinity.
That's good. Why does it sometimes converge?
Oh, because sometimes the bottom will be bigger than the top and it'll continue to converge.
Correct.
Or sometimes the top and the bottom will be the same and converge at the same rate and it'll be 1. So it'll still converge.
No, it'll be diverging because
Oh, it'll
one
be divergent.
plus
so it's
one plus one. Right. Same question, but I might ask you this one. Right. You kind of sussed that one out, so Tim's not allowed to answer. Anybody else apart from Tim? Which one of those 4 answers would work with this one?
I'll go for always.
You nailed it. What was in your brain that made you go that way? It's the right answer.
Because if they both converge, there's no other option because you'd have to have something diverge. If it was diverge and converge, then we'd have a little bit more of a brain problem. But since they both converge, they're multiplied, and number multiplied by number is a number.
Right, and so 2 very small numbers make an even smaller number, and so they converge. I'm just paraphrasing what you said, but yeah, it makes sense to me. Now, do you see those kinds of questions are not your typical homework question? But if I'm doing a question like that, I typically stick that in the multiple choice. So if all else fails, can't you guess and you have a 1 in 4 chance? Side issue here, when I do multiple choices, I've put the right answer in. If I make a mistake and none of the answers are right, that's good news. I just give everybody the 10 points. So if you go and you do a question and none of the 4 answers work, will you assume that I screwed up and just pick C because you know you're getting the points? Right, so just putting that out there. Sometimes I put as one of the choices some other answer. I like that because if I do screw up, it'll be some other answer, right? So I'm cool that way. Have I mentioned that it's in chronological order? I think I did, right? What else? A lot of people are surprised by how hard the final is. If you're really well prepared, it won't be a shock. But if you're half prepared, it will bite your bum. And you might start today with a 3.5 and think, I'm good. Chemistry is the one that's going to kill me. I'm going to spend all my time making sure I pass chemistry. It is quite easy to go down quite a few grade points if you do really badly in the final. For instance, this person here, who was 87%, which you might think is a pretty safe percentage to be, if they got 140 in the final, they'd fail. And I unfortunately get emails from people who say something like, I was 3.2 before the final and now I failed. Did I do that bad in the final? And the answer is yes, you did that bad in the final. So I'm warning you up front, if you're not prepared for this final,